Hi everybody, welcome back to my YouTube video playlist on using RStudio, especially for beginners. And I wanted to post this video a few days ago, but I haven't been able to because I got shingles, which is a nasty skin condition. It doesn't look very nice. And I seem to always get it around this time of year. Okay, it's painful as well because it's the same virus as the chickenpox virus that can come back later in life for whatever reason, probably normally related to stress. But here we are. I'm okay now. Okay, and in previous sessions we looked into some graphing, some graph making, especially the pairs plots. And there's a specific library that you can use to make an improved version of the pairs function, which is called mosaic, okay? And then the code for the plot is pairs_panels. And we also did a correlation diagram, okay? Now both pairs panels, and core plot allow you to put R regression correlation values onto the plot. Okay, so you can produce numbers, R numbers between -1 and +1 to show whether the relationships are positive or negative. And I really like the core plot, heat plot for that because you can also color relationships between variables in red or blue, depending on if they're negative or positive. I really like that. However, the main library that people use for making graphs, nice graphs, in R is ggplot2. And we did a little bit of ggplot2 before, but really we just touched the surface. And I'm hoping that we can do some more ggplot this session and in future weeks. Maybe there's two things that I like the most about ggplot. So we just call it ggplot instead of ggplot2. The first thing is that you can make lots of different types of graphs: bar charts, histograms, box plots, scatter plots, ribbon plots. You can also, it's basically similar code regardless of the kind of plot you're trying to make. So there's really just a couple of lines that you can learn very, very easily, and you just have to change out little bits to make specific plots, and of course for your different data frames and your columns. Now, before we get started, something I wanted to highlight is I often get my console being pretty full from teaching students. You can click this little button in the console, which is the sweeping brush, to clear out the console. Feel free to also clear out your environment by restarting R in the session menu. Okay, that's going to get rid of any data frames that are currently in the memory. Then we go to File, New File, RScript. Okay. This is also an important point to mention that later on we will create a different type of file through the New File option, which is called R Markdown. And R Markdown is used for making reports. Okay. I'll just show you what happens if you push that. Okay, you get this option to create a title and the name of the offer and the date. Then you can save this as a HTML, a PDF, or Word. If you click OK there, it comes up this very default, very short kind of script, which can be knitted to create a report. So the idea is that once you've coded everything that you want in your R script and it works, you can copy code into these boxes here, these light blue boxes in the background. At least they're light blue for me with my color scheme. Then the text that you're seeing here in the dark blue areas is where you actually write all the rest of your report. I'm not going to spoil the fun, create a spoiler by running it right now. We can wait for another session to do that, okay? But what that means is you can eliminate the need for an external Word document, okay? But let's do that later. for now, we will work on making some more ggplots. And it's December 12th today. Okay, so ultimately, in a few weeks or whatever, what I would love to do is stream. You know, it seems like there's a lot of people, or some people watching my videos who I've never met, and if you're one of those people, please leave a note in the comments, and we can stay in touch, and I can give you information about when and where I can stream, and that way you could ask me questions in person, because right now I always just have to come up with a data frame to work on. Okay, you might have your own data, or you want to use a different data frame in R. Note that there's a library called Faraway which contains hundreds, probably hundreds of data frames that you can just install that library, and then you can I can send you a list of all the data frames that are there. They're very diverse, and we can play around and make graphs of those data frames as well. For now, okay, right, we're viewing diamonds, but notice diamonds is part of a library called tidyverse, and that's the reason why I couldn't find it. So we need to make sure that tidyverse is loaded first. In the process of doing this, I will load another library which I really like, called Mosaic. These libraries are installed on my computer. If you don't have them installed, you need to do that first through the Packages tab. Now diamonds will load. And diamonds is one of my go-tos, to be honest, because it's a data frame that contains a lot of data, 54,000 rows, and quite a lot of columns as well. But probably more interesting than that is it's got numerical variables and factors. Okay, the words shown here in the cut column, the clarity column, and the color column. Okay, let's start by using Mosaic to get some summary statistics, but a better version perhaps, or it depends on what you want really, you know, more comprehensive version than the simple summary code. So the summary code will give you summary statistics for every column. Okay, and note that for the numerical columns like caret, we get mins, means, maxes, etc. This is not grouped by anything. So we don't know, for example, the mean caret for a given cut. You can use Mosaic to get the answer to that. I can't remember that I also showed you summarize and group by within the pipe function to do that, but this code here makes it a little bit simpler. Okay, so it's actually much fewer lines if you use this. What we're going to do is we're going to write my diamonds stats. That's what I'll call it anyway. It's back arrow of fav stats. Back arrow symbol being used over and over again in R. Right, data equals diamonds, comma. And now we're going to use exact same syntax that we would use in a model, such as a t-test, an ANOVA, an LM, Kruskel-Wallis. Okay, so if you use this method, you can pretty much copy whatever we're writing here and then just turn favstats into LM to turn it into a model. This isn't a model, this is a summary. But now we're going to see how caret, okay, squiggly line, that's the tilde, cut. Okay, since I called it something, there's a reason I called it something, it's because I wanted to turn it into a data frame so it turns up here in this area instead of in the console. People have different preferences. If you were to take this part out, okay, it will show the results in the console, but if you put it in, then it's named something, it won't show anything straight away when you run it. What you're going to need to do is, I'm just going to create a data frame name, so I'll call it statsdf. It's an easy name to remember. As.data.frame, I think as.tibble works as well. Copy and paste the name of the summary results into here. Okay. Then you can view the stats.df, and this is really how I try to view statistical results as well as data frames. Okay. Yeah, note that, and I don't know if you guys use some of the drop-down menus often, or drop-down option, but it's actually really good for saving time. Instead of if you've got a big data frame name, okay, you just need to write like a few letters and it will find it, and it will suggest that data frame as the thing you want to add. Okay, so now we have the results in a data frame here. Okay, so one of the good things about having this now in a data frame format is that if we wanted to, we could write this data frame with the summary statistics back into our working directory as a CSV file. So if you've got like a colleague that or a supervisor that just wants to see summary statistics as shown here, mins, maxes, means, you could send them this. Okay, so writing as a CSV file, it's a .csv file. We should probably check our working directory because it's going to get written into there. That's where we need to look on our computer. Yeah, I'm so organized. That's new actually. I'm not generally an organized person, but here I am. We've got different sessions for different videos in the YouTube channel, and this is number 6 today. So what we're going to do is we're just going to type write.csv, then brackets, then the name of the data frame in R, which is stats.df, comma, and then let's just call the file name of the CSV the same thing. Okay, that's what it's going to appear as on the computer. Stats.df.csv. You can call this something else, but do not forget the .csv, or else it won't really work. And so you can kind of see that's similar to reading in a CSV file. You always need the .csv at the end. Alright, so orange triangle means it's succeeded. Let's go check in that folder. And we have a newly appearing CSV file. And that's what we need, you know, to go forward. It's what we'll continue to work on in R. Let's make some simple plots first, okay? So I remember last time we made scatter plots. We haven't spent too much time on bar charts, and that would probably be the second biggest plot or most common plot people are making. Bar chart. I'm just going to show you this few differences that exist between the plot code for a scatter plot and a bar chart. We won't bother naming them at the moment. As you remember last time, we had to name the graphs so that we could use patchwork to put them together with pictures. And these pictures, like for example of a diamond or a flower or whatever you want to show in your figure, can be included as part of FigPatch and patchwork. But if we don't name them, we just start with ggplot, and then we do the same code as we did, same style of code as we did last time. Data equals diamonds. Well, actually, let's switch it up. The reason why I'm going to switch it up is because that's going to take quite a long time to graph because it's 50,000 rows. I'm going to introduce you now to some code called slice max, okay? And this is going to allow us to just take, we'll take the rows that have the 50 highest prices, okay? To reduce size of the df. So you remember from before that we create a copy first, because we are making a big change to the data frame. I don't want to overwrite diamonds. That will only overwrite it for me or you, not for everybody using R, by the way. But just important to note that. Pipe function, part of tidyverse. ggplot and dplyr are both brought in when we use tidyverse, which is why you don't see me loading a separate library called dplyr and a separate one called ggplot2. Okay, then it's going to be slice underscore max. This is going to allow us to take just a certain number of rows, okay, that correspond to the maximum values of a column. Okay, so it makes sense we use a price column. And then let's take n equals 50. That's all you need to do here. 50 values from the price column. Okay, that's created a new data frame. And we view that one as well. Diamonds 2. So this will have worked if there's 50 rows shown here. Voila, 50 entries, i.e. 50 rows, and the columns remain untouched. That's easier to work with now. Okay, bar charts. Let's start with ggplot data equals diamonds 2. Okay, AES. So this stands for aesthetics, and this is where we set what we want our x-axis and the y-axis of a graph to be. The first line of any ggplot code looks the same as it, or looks very similar. Okay, sometimes you'll see people skipping this part, data equals, so it just goes straight into diamonds 2. That works as well. But I like to, keep this so people remember what it's showing there. Okay, let's take then x equals cut. Okay, generally bar charts would have groups on the x-axis. That's why we're not making a scatter plot now. It allows us to use these groups or factors on the x-axis. Okay, and then we can do y equals caret. Very consistent with the summary that we ran earlier. This line has a plus at the end, so be careful to use the plus sign here instead of the pipe function. That's the difference. Okay, if you push return, that puts you onto next line with a little space and indentation, just like we had here when we pushed return on the slice max line. Okay, the next line begins geom, and all graphs in ggplot begin geom. Okay. So lots of options here. Maybe we'll come back to some of these other ones later, like geom map, geom polygon. I actually find myself using various of these, throughout the week. Error bars quite often. So error bars are if you wanted to, we would use that if we were plotting statsdf. We would show the bar, or the y as the mean. We would then add extra codes for y min and y max that correspond to the error bars. If you do that, you need this extra line, geom error bar, to be included as well as geom bar. But now we're just going to go geom bar. An important thing here is within the brackets, you need to put stat equals identity. And you don't have to do that necessarily in a scatter plot. It's a bit strange why you have to do that here. Other plots don't have that requirement either. It's something to do with, if you don't include it, it counts the number of rows instead of plots the data, which is unusual considering we set an x and a y. But that works now. Okay, so this is what it's done. It's showing us the total caret of different groups, different cuts, and that's not really what we want. Okay, we're probably not necessarily interested in the total caret. That's why means would probably be more useful here. But if we put fill equals and then choose another group here, like for example clarity, let's see what that does. Okay, so that's added colored groups into the graph. If you were to do color in scatterplot, it's call equals instead of fill equals. What you can do now is we could use the mean data instead of this and have a look at that instead. So I'm going to copy the code because this will emphasize how codes for different graphs is very similar. Bar chart with error bars. We would typically use the standard deviation or standard error as error bars to accompany the mean, and both of those are measures of variability. So if you've got a massively tall or massively big error bar around the mean, that means you probably have less confidence in the mean value. Imagine you've got a mean of 10 but a standard deviation of 50. Well, firstly that'll put you into negative numbers on the lower part of the error bar, but also it suggests that that 10 probably doesn't mean much. Okay. This time we're going to use this statsdf, which is a summary data frame that has the mean in it, and we just want to refer to the right columns here. Okay, so y is going to be the mean, x remains cut. Okay, that's the same in both. What we need now is we need a y min and a y max. Okay, y max equals mean plus SD. So the y min is just the mean minus the SD. That's going to produce an error bar below the top of the mean bar, and the y max is going to produce an error bar above the top of the mean bar. Don't forget that you need one more line here, as I mentioned before, which is geom underscore error bar. Okay. That produces this. So clearly means are very, very useful, because together with the standard deviation, and standard deviation is what you're generally using for observations or trying to describe a population, they can tell a big story which might be lost in the raw data. They can tell an overall story, or they could summarize data. And maybe that's what you want for your project. Already we can see from this that many of the standard deviation error bars overlap with each other for the various cuts. Okay, that could suggest that for the ones that do overlap, okay, let's look at like these two, for example. The means are kind of similar, the standard deviation bars overlap. They might not be significantly different. Their means might not be significantly different. But I'm not going to say for sure, because we would need statistical tests, analysis of variance, LM, non-parametric tests to look at that question further. And we would do that in future weeks, because what those tests are doing, many of them are looking at the means. Okay, non-parametrics look at the medians, like Kruskal-Wallis and Mann-Whitney. Okay. So for now, we've got the means and the error bars shown. Generally, you want to make your graph look as pretty as it can be, so we wouldn't leave the code at that. We would do a plus sign again, and any future lines I'm going to include are mainly for changes to the appearance of the graph. So that's as default as it's going to get. Okay. For now, we're going to use the labs function. And we can do a bunch of things here. We can do title. Title is suggested here. My diamonds graph. You can have, as long as you put it in quotation marks for the title, you can have spaces in between the words, which can be a problem elsewhere in column names. We can add a caption. Caption equals. And note that it's okay for having spaces between on either sides of the equal signs and signs as well. Caption equals, let's make a figure 1. Figure 1, mean caret for different cuts. Okay. The other things you can do is you can change your x-axis and your y-axis names, well, labels, okay, from cut and mean to something else. If you had names in your data frame that had spaces in them when you brought them in as a CSV, those spaces would have been turned into dots, okay? Because R generally doesn't like spaces in column names. If you wanted to put the spaces back in again, you could do it here, okay? So X, we don't have any spaces, but we can just call it cut with a capital C. For the y-axis, y equals, we should probably write mean caret, because mean right now it doesn't tell you too much. Okay, now you can just run that again. Since I didn't name it, it's just going to run instantly when we highlight the whole thing and run it again. These things have been added here. This, and this. The last thing, actually, I'll show you two other things, okay? The first of those is we have an error bar here, which actually goes higher than the tick mark. And generally, the rule is that you want your error bars or your columns, or all your data really, to be lower than the highest tick label shown, okay? So that people know that what the maximum values are, or what approximately the maximum values are. To do this with a numerical axis, you can do this scale y continuous. Okay, that's going to open up some brackets. There's two parts to this, so we're going to do breaks equals seq. Okay, 0. So we're going to set here what we want the minimum and maximum numbers to be. So 2 would make sense. And then the third number, so this is minimum of 0, maximum of 2. The third number is going to be the distance between the tick labels. Okay, so 0.5 makes sense. Okay, now I am missing something here. We need to add this limits equals c, and then here you just set again 0, 2. We don't need to put the 0.5. And that's worked now. So you need two parts, okay? First part where you have the minimum, maximum, and the break distance, and the second part where you just have the minimum and the maximum. The third thing is there's lots of different ways to customize the appearance of the graph in terms of colors and stuff. For example, if we wanted to change these bars from grey to blue, we can add that in the geom bar line. Fill equals needs to be in quotation marks. Okay, so the word blue by itself without quotation marks won't work. Now I'm forgetting that I have a plus in at the end. Make sure that you remove that or else it won't work, and then run it again. So that's blue now. Call equals would do the outline. It's different in a scatter plot, but call in a bar chart will do the outline. So we can do call equals red. Okay, it has done it. Okay. Next thing is we add one more plus sign here, and we can introduce some themes just to make things kind of easier and more appealing, more attractive. So let's see. There's some basic ones already in theme underscore, theme void. Okay, that's not helpful because it gets rid of the axes. What I'm probably going to do is use cowplot. Okay, cowplot is one that has themes in it. Library GD themes has themes in it, and we can just play around with different theme underscores to see what looks nicest. Remember, you can do theme underscore. Here a cowplot one has come up. This wouldn't have shown if we weren't using cowplot library. Okay, so in all of these different templates, the font is different. The whether there's grid lines or not, that's different. The size of the font's different. Theme, I found this one quite recently. Economist white. Okay. I'm not a big fan of that because of the horizontal grid lines in the background. But that's a personal preference thing. That's a bit nicer. Okay, just one last thing is within the error bar line, if you wanted these to be slightly bigger, we could do size equals 2 there. We might have to do AES. I'll check that in a second. Oh, it did work. So we can make these bigger. 1.5. It says here use line width instead, but size still works. So, and there's different codes that you can find online for adjusting the appearance of error bars and bar charts, especially the distance between the blue columns. All of that is customizable. There's lots and lots of references online about using ggplot and adding to the code. But today we've done 6 or 7 lines, which would generally be a great start with your graphs. Since we've already introduced you to how to make a model, it's very, very similar. Okay, we'll come back to this next time, and we will make an ANOVA and t-test and LM in order to actually find out if there is an effect of changing the cut on the caret. So I hope that was helpful. Please subscribe, leave a comment below if you enjoyed and if it was helpful, and then maybe we can get a stream going, but I'll probably only do that if there's enough interest. Have a good day.